Click the bell icon to get latest videos from Ekeeda.
In the previous video, we have seen how to define the random variables and its properties. In this video, we are going to understand what is the concept of cumulative distribution function, how we can associate it with probability, and some of the uses of CDF and how to represent this CDF on graph. Let us start cumulative distribution function by its definition. As we know that the random variable capital X is denoted as X, capital X, and the probability of the event X less than or equals to X is denoted by probability X less than or equals to X, where X is the dummy variable. This is nothing but one more property of the random variable, as it is associated with the event. That is why it is possible to measure the probability of the random variable through the real numbers. Now, CDF cumulative distribution function, it is the probability of all the possible available ranges. Whatever range is available to us because of the random variable, we can use it as the calculation of probability. That distribution of the probability is defined as cumulative distribution function. Now, CDF is denoted by, this cumulative distribution function is denoted by f subscript capital X, which is nothing but a random variable of X. It is also a function of X. The meaning of this f subscript capital X small x is that this function is associated with this random variable through its event, and this X can take any value. For example, when I am throwing a dice, when we are throwing a dice, this X random variable can take any value. When I am defining a cumulative distribution function that for that particular event X, then I can denote it by f of X, where X is the event of the rolling of dice, and this small x can take any value. Let me say what is the probability of getting 1, probability of getting 2, probability of getting 3. So this random variable X is associating through the real numbers. As the random variable is associated with the event, it is possible to measure the probability for all the possible ranges. So with the help of this random variable, we will find out the probability on the real number line. CDF is equals to fx of X, which is nothing but the probability of random variable which is less than X. This is how we can define the cumulative distribution function. It is the function of random variable whose probability is less than some dummy variable on the real number line. This is minus infinity. If X is less than X, then I can say that this is the possible range from minus infinity to X. I can define the function minus infinity to X, because capital X is less than or equals to X. But one more thing is to consider that this X can take, as it is a dummy variable and it is also assumed by us, so this value of small x is varying from minus infinity to plus infinity. It can take any value from minus infinity to plus infinity, but for this particular case, for this particular case, capital X is less than or equals to X. So I can say that the range of the X is, this range of this capital X random variable is from minus infinity to X. But this dummy variable, this capital X random variable is defined from minus infinity to X, and this dummy variable small x can take value from minus infinity to plus infinity. Now let us understand more about the CDF through an example. We are taking the case of rolling of dice. As we know that the sample space for the rolling of dice is capital S, which is equals to 1, 2, 3, 4, 5, 6. These are the sample points of the sample space. Now I am defining some random variables. Capital X is a random variable whose value is less than or equals to 1. So what we are doing, we are trying to find out the probability of the random variable whose value is less than or equals to 1. So there is only one case when the value is just equals to 1. It is not possible to get the value which is less than 1 in the dice. So I can say that I can just find out the value of capital X is equals to 1. Similarly, for capital X is less than 2, it means that less than or 2, so the probability is 1 or 2. I can get 1 because it is less than 2 plus probability of 2 because it is equals to. Similarly, for less than 3, 1, 2 and 3. Probability of X is less than or equals to case consists of all the events of 1, 2, 3, 4, 5, 6. Probability of X is equals to 1. The sample point is 1, that just 1, and the sample space is 6. So probability of getting any number when we are rolling a dice is always equals to 1 by 6. So it is 1 by 6. This is 1 by 6 plus 1 by 6, that is 2 by 6. Similarly, this is 1 by 6 plus 1 by 6 plus 1 by 6, 3 by 6. This is 4 by 6. This is 5 by 6. This is 6 by 6, which is nothing, equals to 1. Okay, so this is our probability distribution for a particular random variables. This is the x-axis which is defined for dummy variable x. This dummy variable small x, fx random variable, this random variable, bracket x of I is the CDF for this particular event of rolling of dice. CDF is defined as f of x of small xi. When I can take values equals to 1, 2, 3. So value of this dummy variable can be 1, 2, 3, 4, 5, 6. For this particular 1, 2, 3, 4, 5, 6 values, we will define our CDF, cumulative distribution function, which is nothing but associated with the probability of these numbers. Let us look at the graph that how we can associate this CDF with these probabilities of random variable x is less than or equals to 1, 2, 3, 4, 5, 6. This is the x-axis which I am defining for this dummy variable x. This dummy variable can take values 0, 1, 2, 3, 4, 5 and 6. For this particular values, I will get my distribution function fx of x. This fx of x, that is our CDF, is nothing but the probability. It is defined as the probability for this particular events. So probability, let me take as 0, 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, or equals to 1. This is nothing but the probability is equals to 1/6. When it is in between x of less than 2 at particular x of less than 2, I can say that the probability is 2/6. Similarly, I can define the probability for 3. This is what we are getting, a staircases form when x is, let us take this value, when x is less than or equals to 2, that particular probability is equals to 2/6, that is 1/2. So when x is less than or equals to 2, and this is what we are getting in the form of a staircases. The function is increasing. When the dummy variable is 6, that is when x is value of 6, the function is constant, that it is always equals to 1, because 6 is a case when we are defining the probability of getting all the sample points. If it is all the events are always certain, that it is always true that we are getting any number, at least we are getting 1, 2, 3, 4, 5, 6, any number, we always throw a dice, we will get a number. So this is a certain events, that's why its probability is always equals to 1. So this is always equals to 1, and it is starting from 0. This function is increasing in nature. This is how it is increasing. This f of x is a increasing function, always increasing in nature, because the probability is increasing like this. At 1 it is equals to 1/6. At 2 we always take the intervals, difference of the interval, it is 1/6. It is true that it is also 1/6 difference, it is also 1/6, this interval difference for getting 4. For getting 5 it is 1/6, for getting 6 it is also 1/6. As we know that the probability of getting 1 or 2 or 3 or 4 is always equals to 1/6, always 1/6, 1/6, 1/6, 1/6, 1/6, 1/6, which we are getting. And in between 1 to 2 the probability is constant, it is not changing, it is jumping after 2. Similarly after 3 it will take a jump. So in between 1 or 2 the probability is constant and it is changing at 2. Similarly at 3, at 4, at 5 and at 6. This is how we can represent the CDF of fx of x, or CDF for a dummy variable x, which is showing us that this CDF is a increasing function. It's a increasing function and it is in the form of a staircases. So increasing function, and this value is 1, 2, 3, 4, 5, 6. One more point, that they are countable. This is how we can define the cumulative distribution function or CDF for any kind of random variable. In the next video, we will see the properties of CDF and some of the problems which are based on CDF. Thank you for watching this video. Stay tuned with Ekeeda and do subscribe our channel Ekeeda.